Oh, yeah.
But
Oh, it looks like we're live now.
We are now live.
All right, well, I think I'm going to go ahead and get started because it's 2 o'clock. Does that sound good? Welcome to the virtual 2020 AOCS Annual Meeting and Expo live stream. I'm Jill Mosier. I'm a research chemist at the USDA Agricultural Research Service in Peoria, Illinois. In a moment, Rick Delaporta, Senior Principal Scientist at PepsiCo Frito-Lay, will provide a considered review of the current methodologies used for understanding the behavior of oils used for frying by academic researchers and how they can be applied to the needs of different industries. Rick received his MS in chemistry from UT at Dallas and has 34 years experience in analytical research with a focus on fats and oils. He has been an active AOCS member and volunteer since 1991. Questions from the live stream discussion will be answered at the conclusion of the presentation. We look forward to the conversation. With that, I will turn it over to Rick.
thank you, Jill. And thank you, American Oil Chemist Society, for providing us the opportunity to share our research and our thoughts this year, even if we are doing it from our homes. First and foremost, I have to say that these opinions are mine and they do not necessarily reflect the position or policy of my company, PepsiCo Inc. So only hold it against me if you disagree with me. I'd like to talk a little bit today about what I think is a necessary development in our analytical models, the alignment of academic and industry. And like Jill says, I've got a lot of history here. I've been doing Pepsi work for 36 years and oils and fats for 34 of those. I've been an active member of AOCS. Most of my time is spent figuring out how to make oil work better for our frying systems. So let's just talk about what the challenge is. What goes on when we fry? I mean, scientifically, lots of things go on. And we love to characterize every one of those unique, isolatable reactions from an academic standpoint, so we know what becomes what. But when it comes to my world, the commercial world, individual reactions aren't individual. They're part of a whole complex frying array that goes on. So we have to talk in terms of the application. The application on the academic side allows you to use various and sundry frying protocols to produce data and results to drive a point home, rather than focus on how does it apply. And they're very idealized test systems, and they have to be, because you've got to be very focused. The outcome is very important to understand the beginning to the end. In the real world, we have two types of frying systems, either batch or continuous. And our focus is on the consumer. Either they're going to eat it right away, or they're going to eat it after it's sat on a shelf or in a freezer, and then they cook it again for some period of time. And we cook all kinds of things. You've been to the grocery store, you've been to the fast food places, you've looked on the shelf in the snack food aisle. We fry a lot of stuff. So it's all different in how it reacts in the frying. So there's a big difference to interpreting the results depending on the protocol to generate the data. And this is where the alignment comes in my mind. How do we connect this research and commercial application? We want to expedite transfer of learnings. First, you have to ask the right questions. What are you trying to resolve? Who are you trying to resolve it for? And then find an application very specific in the market that can then be tested on the bench. This helps me in my job when I can pull up some research that is directly linkable to an oil being used to fry potatoes or tortilla chips or plantains or chicken. We deal with a lot of different types of frying applications. So I've got some new questions. You know, designing with the end in mind. Ask the question, where does the flavor start? Where does it change? What causes it? How is the product stored? Is the oil stored up front? How's the oil stored after you're done frying? Is it reused? And then what about that product stability after it's released from that? You know, what's the expectation for shelf life? Also, we also have to consider the health, right? Everybody wants low saturates, no trans, lower oil content. Even the total polar content is critical in some cases. So how does that apply from an academic research standpoint and translate to the industry? And of course, we all want to save money in industry. We need low cost raw materials. We need to get them to live longer in the fryer. So how does the productivity aspect play? And how do you address that in an academic setting? My ultimate measure is the consumer's desire to keep eating that product when it's done. So we need to know what key parameters are measured and monitored during the production and post-production aspects, and how do they translate? And are the actual testing protocols for frying and analytical translatable from the bench to the production site or to a restaurant? So look at the methods. This simple chart I put together. I had a little fun here. Everything with a smile can be done in academics and in the R&D lab. When you come to the plant, a production plant has limited capability for analysis. Certain tests can be done pretty easily. Certain tests require equipment that they can't put in. And simple things like maybe a stability measure or checking the flavor of the product before they put it in the bag, easy to do. Taken to the restaurant, they've got very limited capability to test the oil they're using. They rely a lot on the supplier providing quality oil and on certain support companies giving them testing techniques that they can at least relate to the oil quality, the longevity of the oil in their batch fryers, and the way the consumer is going to respond to it. I don't know how many of you have been to a restaurant and ordered French fries that came out greasy and soggy, but that's bad frying oil. And you should turn those back in. It's really the consumer response that the restaurants respond to and how they treat that oil. So they don't really have a lot of testing methods. So we have to give them better information so they'll understand when they fry what's going to happen in that oil. A lot of secondary methodology can be used. We have Fourier transform infrared and near infrared. We have the differential scanning calorimetry, EPR, NMR, the potentiometry, those total polar devices. Companies like Food Lab and Safe Test, which is now being sold by MT Bio, by the way, they have quick kits that can be used in the restaurant industry to check oil quality. DSC and NMR and EPR probably not so much for the restaurant, but in most analytical labs in production facilities, IR, NIR, NMR, even the total polars can be used quite easily. And so long as we know what the data means in terms of the oil quality and the product quality, that pays the benefits, right? All of these, though, require very specific and repeatable sampling protocols so they can be understood on the commercial end when it comes to actually utilizing them. A couple of examples, what goes on? Restaurants, batch fryers, easy to do in the academic lab, right? Fry daddies, mini batch fryers. The restaurants themselves have limited testing capability, like we said, but their shelf life is minutes. Comes out of the fryer, gets served to the consumer. The consumer's going to tell them right away it's good or bad. If it's bad, restaurant loses business. Their main concerns with oil quality and fry life revolve around smoke point, how much polymer builds up, free fatty acid, total polars, the color and flavor of the oil. They have test kits for a lot of this, and a lot of restaurants will use them to keep their oil at least in good enough shape so they don't have to keep throwing it away and they don't get a lot of consumer complaints. They save money by fewer oil changeouts, which means using the oil in the right way and replenishing it at the right time. When it comes to a continuous fryer, you can't really do these in the academic lab. You can simulate to a degree. It's very intensive, but it can be done. And especially if you work with an industry partner that understands or utilizes continuous fryers, they can help with the simulation in terms of the oil turnover rate, throughput of the product, the replenishment of the oil, and actual measuring of the quality. There are all kinds of products I started telling you about, right? Long-term shelf life, snack chips. In the US, you have snack chips that have maybe a 2-month shelf life or maybe 6 months of shelf life. You pay more for 6 months shelf life. because it means we did a much higher quality job in making that product in the bag. When it comes to par fry frozen, you're either refrying or baking it at the time of use at home, and the oil quality plays a big role in what that finished product tastes like. So by working with an industry, you can answer the questions that will help you create better research. You know, like I said, the concerns are always oil quality and consumer acceptability, especially for a product that's going to sit on a shelf for a long period of time. There's a big understanding that has to be achieved in the storage environments. What is the package? What atmosphere is in that bag? What range of temperature will it see? And what's the humidity, moisture effect? These all play a role in the quality of that finished product when the consumer experiences it. And then, of course, a lot of our productivity initiatives require cost reduction, using lower cost oil or putting less oil in a product, and still maintain that shelf life quality that the consumer expects from it. And last, but certainly not least, purely academic, highly specific research is critical. I can't stress that enough. Without frontline academic level studies, we don't get anywhere in an industry. We need that background. I also say don't hesitate to publish with suggestions or recommendations to an application. If you've got something in mind, publish it. Get control of it before an industry partner does, because an industry partner may put some restrictions on publications, and then you have to work around the publication side of your need from an academic standpoint. It's better to publish and patent some research and then let industry come to you. And then the final key point is you have to understand what regulatory constraints that there are and consider the timing for approval of things like additives. Anything we put into food has to be approved by the government. And it may not be just the US government, it's going to be international governments. And while the FDA here may say it's okay to put rosemary in as an antioxidant, it certainly isn't that way in countries like Thailand and other places where it's considered a flavor, but it's not allowed as an antioxidant. So there's always a timing to prove out that it's safe for people, the grass conditions. So what do I recommend? Set yourself a standard for comparison based on the desired end usage. Know the backstory. What are we working toward? And then have a known to compare it against. I like to use palmolene and high oleic sunflower, two very stable oils, historically have been the benchmark oils for my oil studies when I'm looking at all of the other oils. And then I have to make a product that achieves the same endpoint. Establishing the background conditions is critical. I simulate the operating conditions of where the oil will be used and the types of fryers that I have to deal with. I get packaging, I get storage conditions. I do all these little fun packs of product that we then age and taste, as well as do the analyticals, headspace analyticals and things like that to know what changed and compare that to the control. It's consumer feedback. The industry is driven by consumer feedback. We have to get them to want to buy our product because it tastes good, it appeals to them in some way. It's not hit or miss. It's very strongly driven by academic research for us. So that's pretty much my thinking on how we can align research to drive the industry to create better products, and then feed back to the academics to increase their research. So I thank the American Oil Society Lipid Oxidation Quality and Analytical Divisions for allowing me this. My R&D TDC team, and we changed our name recently. It's now Technical Insights, Digital Management, and Compliance. So at this point, if you have any questions, I've left a good 5 minutes, and feel free to send them my way.
We're not seeing any questions in the chat at the moment, but we can give it just another minute in case people are typing.
While we're waiting, Rick, I have a question. You mentioned antioxidants and sort of the regulatory issues. So what do researchers and academics do to work with that? Because in academics, you can't publish something that's already been done. So academics are looking at what new antioxidants are out there. So how can we work with industry to determine whether these antioxidants will be, feasible for actual end use? Does that make sense?
Yeah, no, I understand the question, and that's a good one. A lot of it has to do with how similar is an antioxidant chemistry to an improved antioxidant, and how acceptable will it be from a testing standpoint. They have to go through consumer response, they have to go through toxicology. I know the biggest challenge I have with rosemary is the carnosic carnosol level has a limitation in countries like in Russia. They don't allow more than 50 ppm of carnosol carnosic in the finished product level. So that means I have to control how much rosemary gets carried through. Other countries, it's approved as, like I said, it's approved as a seasoning, but not as an additive. Tocopherol is restricted in some countries as an additive. I think the best thing is when you look at new antioxidants, especially natural ones, comparing them to what exists already out there to see how close they are, and maybe you can piggyback on approval applications.
Okay. Well, we do have a few more questions here, so I'll go ahead and ask them. The first is, can you share your experience for equipment for peroxide value from industry?
Well, yeah, it's pretty simple. The classic obviously is the ionometric titration, but and I'm not plugging equipment here, but this is stuff I've used. Both the Safe Test and the CDR Food Lab do have a very clean green chemistry for measuring peroxide, free fatty acid, anisine value. They're kit chemistries, so you just inject and it's colorimetric and it's been calibrated against actual values. Those are the ones that I've experienced.
Okay. The next question is, what type of oil is suitable for frying purposes? For example, high oleic oils?
Well, again, it's application. All oils, except for extra virgins, are great for frying. Extra virgin oils tend to smoke a lot, so you fry at lower temperatures, which is suitable for some applications. The end product, again, with high oleic, means your finished product's going to retain more stability than if you fried with classic sun. In the fryer, the oxidation and polymerization levels are going to be lower with high oleics than they are with the classics. So you modify your frying technique to reduce that aspect of the application. Flavor plays a big role. Sunflowers and canolas are very lightly flavored when you're frying them. You get to corns and palms and soys, you can start tasting a lot of the flavor of the oil as it oxidizes and creates its own flavor. So, I use a variety of oils for cooking at home depending on what I'm cooking. If I'm batter frying something, I'll go with corn oil. But if I'm sauteing a piece of fish, some shrimp, I'll go with canola because it doesn't impart extra flavor. So.
Okay. All right. We actually had a follow-up question to that previous question about peroxide value. The question is, is there any new equipment that has been embraced by industry? I'm assuming for peroxide value analysis or other analyses.
Aside from those two from CDR Food Lab and the Safe Test, I don't know of any new equipment. There are some automated systems that can be applied. it depends on how you can set up in your plant to do it automatically, sampling from the oil system into a standing cabinet, which has the chemical system already in it. But there haven't been a whole lot of innovations for those very simple, normal colorimetric titrations, except for to make them greener, so you don't have to have the large amount of waste chemicals.
Okay. The next question is, what is the ideal temperature to fry at home?
Well, it's about the same as frying in industry. If you're frying heavy things, potatoes, chicken, you won't fry them up above 355 to 365. Don't go too much above 380 because you'll start to get to a smoky level on that oil. Since you're heating it from the bottom of the pan is going to be much hotter than the oil is. And if you use a thermometer, it will help a lot because you can turn the heat down. I gave a kick out of cooking shows that tell people you have more than one setting on the oven. It's not just high on the stove. You can go to medium. Oil has twice the heat capacity of water, so it doesn't have to be kept as hot to maintain temperature. So yes, but if you're frying smaller things like shrimp or seafood in particular, fry it down around 325. It cooks so fast and you won't burn it.
All right. Do you think that labs using similar equipment or hands-on work are a good simulation for the restaurant or industrial environments? And if not, what do you suggest?
I definitely think restaurants are very easy to simulate in the lab because they do batch fry and they don't do continuous batch fry. They drop a bunch of fries every time they need it. The fryer stays hot the whole time. Their big concern, again, is polymerization, that development of that heavy, oily, greasy flavor. And if they let the oil go too far in free fatty acid smoke. So they can test for free fatty acid pretty quickly with these little kits and keep their fryer under control. Continuous batch, like we would use to make kettle chips, for example. There was a How It's Made show on the Food Channel that showed this small kettle company and how they actually just put in so many pounds of slices of potato, fry them, pull them out, and get the next batch going. You can simulate that too. That's back to back to back. Right? Every time a batch comes out, another batch goes in. So the turnover, and we're talking about hours of turnover versus days. In a restaurant, it may take 3 days to replace an entire fryer. In a continuous batch fryer, it could take anywhere from 30 to 40 hours to exchange all that oil. A continuous fryer, I put 5,000 pounds of potato chips out every hour. I'm putting a full load of fryer oil in less than 8 hours. So I reach an equilibrium that you don't achieve in batch frying. So I think the answer is yes. Academically, you can simulate batch, but like I said, it's tough to simulate the industrial turnover of a continuous fryer.
Okay, next question is, there's a lot of industry data and knowledge out there. How can these be shared with academic researchers, or are they available?
Well, most of us aren't allowed to publish what we know. Trade secret, business advantage. It does filter out, though. A lot of my mentors are out there as consultants, and they can give clues to what's been done. But I'll tell you, most of what I've done comes from academic research. It's just the way I apply it and what I learned from it is the real key. You can get a lot of information from the frying manufacturers. One of the biggest ones in the US is Heat and Control. They know a lot about frying. They make continuous fryers, they make batch fryers. They can give you a lot of the parameters of production. There are details that they don't know from how I might tune my fryer to make potato chips a certain way, but they certainly know the basics. And so that would be a good place to start if you're trying to look to simulate an industrial system by understanding, what do we buy and use in that big plant that sits out there.
Right. Okay. this is kind of a similar question, but from your perspective, what more could or should AOCS be doing to support alignment between industry, academia, and government researchers?
I think forums like this are the best way. Get people who work in the industries to come and talk about, in the generalist terms like I'm using, what we do, what we need, and have open conversations. Never hesitate to come up if we happen to meet all together next year live. I always enjoy having one-on-one conversations with both academics and industry professionals who might be new to the business of oils and fats and frying, and share the knowledge. I generate lots of ideas for myself by talking to researchers who are doing fun things that I can't do in my lab, but I can then take forward. In fact, Mrs. Jill is one of the people I play a lot of information from with her research from ARS, because I don't have the time in my system to do full background research. But if you saw her presentation today, you know where my next research is going.
Next question. How is oxidation prevented in highly unsaturated frying oils?
Don't let it breathe. You've got to keep the air out of it. That's the simple answer. It's a process control system that would be in place. You can put nitrogen curtains on the inlet and outlet of a fryer. You can put steam, pressurized steam in the fryer, anything that inhibits the aeration effect in the fryer. There's additives. TBHQ is a great antioxidant. It doesn't really survive total frying, but it'll keep the initial oxidation from happening. Post-fry, once that product comes out, it's still in that same oil. So if you've got a low oxidation coming out, you've got a better chance of it making shelf life. Then it's, how do you package it? The best packaging out there is a metallized can full of nitrogen. No light, no air, no moisture, can't leak out, and that product will stay good for a year. You open the can, then you get about an hour.
In the case of red palm olein, have you tested the effect of degradation of the oil color on the color of the final product?
Unfortunately, no. Our business model for oil color is less than 4 red because it directly impacts the color of the potato chip. So I haven't done any studies that look at how that keratin changes color over time of heating.
You're getting a lot of questions here, Rick. Okay, next one is, how would you recommend to test the effect of antioxidants in frying oils?
Okay, doesn't that question answer itself? You fry without the antioxidant, then you add the antioxidant in different levels, and then you test the quality of the oil, and then you test the quality of that material coming out of the oil, whether it's a potato or a tortilla or whatever you fried, under some of the conditions that have been listed for years out of, ARS Labs has done a lot of work where they put the product into a shelf life and do sensory on it. But it really is all about, dose effect, and then what shelf life and what aspect of the oil quality you're trying to control. And I'll let you in on a secret. Tocopherols fool you into thinking they're not antioxidants when you add them to the oil, but when you measure them in the fryer, they don't usually change by very much. So they are, what I've learned is that they are post-fry antioxidants, because I've done some work and had oils that shouldn't survive post-fry make shelf life as if they were high oleics by just having tocopherol added above and beyond the native level, at least 1,000 ppm. So you can't trust the OSI to tell you that you've increased the stability of the oil, because I've been doing, one of my fun researches right now is comparing a pressurized oxidation versus OSI, and you see a significant difference in the results when you add tocopherol under pressure system than with a rapid aeration system. So the best way is to just cook something. and then taste it and age it and taste it again.
Okay. Have you heard about high oleic palm oil being used in frying applications?
There's not enough high oleic palm oil available for most commercial applications. There's some out there for testing purposes. It would be nice if it was high oleic instead of high saturate and at the same price. And if there were 10 billion pounds of it available, everybody in the world would be using it. Yeah, it's very good, like all the high oleics. The one drawback I found was it was very low in tocopherol. It's got tocotrienols though, but still at levels that are significantly below other vegetable oils, except for sunflower. Sunflower just doesn't like tocopherol for some reason.
Do you know if trans fatty acids are generated in the frying process in homes?
In homes, I don't know. I'm sure somebody's done some studies. Most of the trans fatty acid work I've done has dealt with my frying systems, which are, high turnover, 360-degree Fahrenheit systems. We've actually published a paper through our nutrition group about a decade ago now that showed no increase in trans fat in corn oil that was fried for a week in our tortilla chip system. But based on thermal chemistry, if you do a lot of thin film frying, like you saute a lot, you typically use fresh oil, so it's not a problem. But if you keep using the oil over and over again, you will get an increase in trans. There's no way to measure it, and I don't have a sense of how much the increase would be in that condition.
Okay. Last question from the Q&A that I can see is somebody wrote in, I think that refined olive oil is suitable as a frying oil. What is your opinion?
Oh, definitely. If you can afford it, it's as good as high oleic sun, in fact, a little better. The one challenge I've seen with refined olive oils is the initial oil quality, the stability function. Depending on how that oil was pressed out and processed, I've seen 10-hour OSI and 22-hour OSI. And if I'm going to pick, I'm picking 22 hours. So, but from a frying standpoint, it fries beautifully. It doesn't smoke. It's got the same smoke flash fire as high oleic sun. So yeah, it's just expensive. Same thing with refined avocado oil, another really great oil, and it's very expensive. I mean, it's 5 times higher per pound than palm.
Yeah. Okay.
Maybe more, maybe 6.
Actually, we did have a few more questions come in. Do you still have time to answer questions, Rick?
Sure, I can answer a couple more.
Okay. Question is, do you see differences in tocopherols, alpha versus gamma in shelf life studies?
Not in our shelf life studies. We're talking normal, room temperature studies that doesn't seem to change the tocopherol significantly under those conditions. I do see changes in tocopherol in certain frying conditions where there's much higher thermal and oxidative stress. But once it's out of the fryer and in a stable condition, there's very little change that's noticed.
Okay. And the next question is there something like a friability index to define as much as possible the best quality frying oil?
There's not a formal friability index. It really is almost a personal choice. What do you want out of the oil, right? High stability oils are obviously going to be the best, whether it's high saturated oils like palm or high oleic sun, soy, canola. But this, I've seen all kinds of scoring systems where they take the oleic, linolenic ratios and apply multipliers to them to give you an index. It really is how you're using the oil. I mean, I get the same performance out of rapeseed oil, classic canola, as I do out of high oleic canola because the conditions for frying control the oil quality. Once it comes out of the fryer, I have to be more careful. But it's really more about what do you want to sell? You want to sell a premium product, put it in refined olive oil. People will pay money for that. You want to make money on the product, put it in refined, even middle oleic, sunflower oil or corn oil, because at least then your profit margin's there.
Okay. And do you know a rapid method for carnosic acid analysis?
No. It's HPLC. There is a way to measure activity using DPPH, dipicryl something or other, I can never pronounce it. But to get the actual concentrations, there's no rapid method. It's HPLC extraction.
Right. Okay. All right. Well, I think that was the last question.
Okay.
So, okay. Yep. Dan says there's no more questions. So once again, I'd like to thank Rick Delaporta for your excellent presentation. I believe that you also have a recorded presentation on the AOCS meeting website. So people have 1 year to view that, and you can always email Rick to ask any follow-up questions. So thank you very much again, Rick.
You're welcome. And thank you everybody for